Today we're going to work on the standard form worksheet. Standard form, we remember that linear equations written in standard form are in this format. And the only variables that we understand, or at least recognize, should I say, are the x and the y. And the x and the y are coordinates. A, B, and C don't hold any value in the sense of solving or finding the slope or finding anything of that nature. We will utilize them to find things, but it's not like we can look at A or look at B or look at C and say that's the slope, that's the y-intercept. So when linear equations are in standard form, what we do is we use them we're going to use them to find the x and the y-intercepts. So when we have an equation in standard form, like 5x minus 2y equals -10, we're going to find the x and the y-intercept. And we do that quite easily in that, sorry, I'm going to write the equation over here. 5x minus 2y equals -10. And if we were going to find the x-intercept, we know that all x-intercepts have a y value of 0. So we're going to plug in 0 for y in this equation. So if we rewrite that starting equation, 5x minus 2y equals -10, where we see the y, we're going to substitute a 0 in for that value. So we get 5x minus 2 times 0, substituting the 0 in for the y, from this statement right here. And then we're going to simplify it. We're going to simplify it. 5x minus 0 equals -10. 5x minus 0 is 5x. We're going to solve for the variable. 5 is multiplying the x, so the inverse of multiplying 5 is dividing 5. And we get x equals -2. So that coordinate would be -2 for x and 0 for y. So that coordinate, -2, 0, -2 for the x, 0 for the y, is the x-intercept. If we look at that location, -2, 0, -2, 0 is right here. And that is on the x-intercept, hence why it's considered the x-intercept. Now, we're going to do the same thing, but this time we're going to do it for the y-intercept. And we know that all y-intercepts have an x value of 0. So we take that starting equation, 5x minus 2y equals -10. But this time we're going to plug 0 in for our x value. And then we're going to simplify. And I know I'm going to use blue in a second. So we have 5 times 0 minus 2y equals -10. 5 times 0 is 0. Minus 2y is -10. 0 minus 2y is -2y. We're going to divide by -2. And we get y equals +5. And that's going to be our y-intercept. What did we plug in for x? We plugged in 0 for x. When we plugged in 0 for x, we got 5 for y. So that coordinate would be 0 for x, 5 for y. And that would be considered our y-intercept. So if we plotted that point 0, 5, 0 on the x, 5 on the y, does that. So 0, 5 is how we write that coordinate. We now have 2 points. We draw a line. And we just graph that linear equation, which was in standard form. And we're going to just repeat that for all of these equations. We're going to do the same exact step each time. We're going to find the x-intercept. We're going to put 0 in for y. So we take this equation and we're going to plug in 0 for y. So we x minus 0 equals -4. X equals -4. That is going to be my x-intercept. Then we find the y-intercept. We're going to put 0 in for x. If we're looking for the y, the other one gets the 0. So we use the starting equation, and now we plug it in for that variable. 0 minus y equals -4. Negative y equals -4. We're going to divide by -1. We get y equals 4. And that is my y-intercept. Let's plot those 2 points. X-intercept is -4. We go to the x-axis. We find -4. Y-intercept is 4. We go on the y-axis and we find +4. We have those 2 points. We connect them. We put arrows on the end of our lines to show that there are an infinite number of solutions. And then we write the coordinates next to the points. Nice and easy, nice and efficient. We write the starting equation. We separate it. We write x-intercept, y equals 0. We rewrite that equation just so we have a reference. And now we plug in the point for the variable, or that value in for the variable. 4 times 0, x plus 0 equals -8, x equals -8. And we do the y-intercept. X equals 0. We rewrite the starting problem, and then we plug it in for the variable. 0 in for x. We get 4y equals -8. Divide by 4. We get y equals -2. So x, where is x? What? -8. Let's make sure we did that correctly. We did. This graph went off of the chart. That is unfortunate. So that would probably be -8, and y equals -2. And I just checked to make sure that I didn't make a mistake. Oftentimes when it goes off the graph, you would be somewhat suspect. Make sure that you're correct in your calculations and your rewriting. So this is going to be -8, 0. This is going to be 0, -2. And that's all I need from you. 2 points, 2 coordinates, an arrow with a line with 2 arrows. Number 4, 2x plus y equals -2. Let's find the x-intercept. Y equals 0. 2x plus y equals -2. 2x plus 0. We're plugging the 0 in for that variable. And then simplifying. 2x plus 0 is 2x. And now we're isolating the variable x. We're dividing by 2. And we get x equals -1. And that is my x-intercept. That's the x value when we plug 0 in for y. Now we're going to find the y-intercept. And all y-intercepts have an x value of 0. So the starting equation, plug 0 in for x, 2 times 0. 0 plus y equals -2. Y equals -2. So that coordinate is going to be 0, -2. So our x-intercept is -1. Go to the x-axis, find -1. Y equals -2. Go to the y-axis, find -2. Connect. That was a horrible connect the dots. That's better. Not perfect. -1, 0. And 0, -2. You must have parentheses around your coordinates. X plus y equals -5. X-intercept, y equals 0. X plus y equals -5. 0 in for y. We get x equals -5. Y-intercept, x equals 0. The starting equation, we're We're going to plug in 0 for x, and we get y equals -5. So the x-intercept is going to be -5. The y-intercept is going to be -5. And we have the arrows. So -5, 0, 0, -5. And that's our equation. Ooh, so here's our first interesting. What should we notice? We should notice that there's one variable. So if we notice there's one variable, we can solve it in that manner. This is going to be a really interesting one because the y equals 0. I made this double hard. So if we were going to write this equation in standard form in ax plus by equals c, we would write 0x plus y equals 0. And now we could break them up. X-intercept, we put 0 in for y. This is going to be so crazy. Sorry. We put 0 in for y. Oh, boy, is there going to be. So 0x plus 0 is 0x. Then we divide by 0, and we can't divide by 0. So there is going to be no x-intercept, which is kind of the case. Let's do the y-intercept. Y-intercept, x equals 0. So we have 0x plus y equals 0. So we'll plug in the 0 for x. So that's 0 plus y equals 0. 0 plus y, if we add 0 to y, we just get y. And this is my y-intercept. So I go on the y-axis and I make a dot. That is true. Now, this is where, so it's going to be, where is y going to be 0? So this coordinate is 0, 0. We agree with that. Can you show me another place where my y value, let's move this a little bit, let's move this up, where my y value is also 0? Let's take this point, whoops. Let's take this point. What's that coordinate? That coordinate is -4, 0. So notice my y value is 0. My y value is 0. What about this point? 6, 0. Oh, my y value is 0. So if I connect those dots, that is the graph of my line. We actually already have the coordinates. So this one's a little tricky. That's why I sort of giggled in a somewhat mischievous way, is this is going to be crazy. Notice we said down here, there is no x-intercept, meaning this line doesn't cross the x-axis. Well, it doesn't cross it. It literally lies on it. So this is one of those, that's less than 1% question. That's more than a quarterback crunch, super difficult, hard question. This one's a very, very unique question. Let's look at this one. So this is more traditional. Oh, nope, it's not traditional. It's going to be, I gave you back-to-back questions that are so unique and not the traditional. So, but let's keep doing it. Let's see what we get that gives us things that make us go, So we rewrite the starting equation. And this part isn't the part. This is still traditional. 2x plus 0 equals 0. 2x equals 0. Divide by 2. Divide by 2. X equals 0. We can have 0 in the numerator. We just can't have 0 in the denominator. So my x-intercept is 0. And this is where it gets fun. This is where you sort of, you may see where I'm already going with this equation. So we plug 0 in for x. We get 0 plus y equals 0. We get y equals 0. Now, two problems before, we had the same intercepts, -5 on the x and -5 on the y. And that was okay. It didn't create anything crazy. But in this problem, we notice that our x and our y intercepts are the same. So on the x-axis, I make a dot at 0, and on the y-axis, I make a dot at 0. What's the problem here, students? Yes, we only have 1 point. And how many points do we need to graph a line? Yes. So there's a number of things that you can do. You can find a solution, and we can go back to how do we find solutions. No, let's not write it there. How do we find solutions to linear equations? Do you remember the H chart? Do you remember making these charts? Hopefully you do. So my equation was 2x plus y equals 0. 2x plus y equals 0. 2x plus y equals 0. So we're going to pick a value. Let's pick 1. 1's a good, nice, easy number. And we're going to plug that in for our x. So, and we're going to simplify. And then we're going to isolate. And we get y equals -2. So when x equaled 1, my y value is -2. And that is a point. That's a coordinate that we can use. It's a solution. It makes a true value. So 1, -2. 1, -2. I have my second point. That was not on the line or through those dots. That is 0, 0. And this is 1, -2. So that's the way that you're going to do that. When your x and y intercept are both 0, you're going to have to make an H chart, and you're going to have to find a secondary point. You can pick any number. You didn't have to pick 1. You could have picked -1 or 2 or 5. You can't pick 0 because we've already done 0. We plugged in 0. In fact, we plugged in 0 for x and y because it's the same point. Those intercepts are the same points. Hence why when you plugged in x, when you plugged in y for 0, you got x, 0 for x. When you plugged in 0 for x, you better get 0 for y because you've already done it. Those points shouldn't change. So we had to find a secondary by choosing another y, plugging it in, and figuring out what our, you had to plug in an x and figure out what a y value for that x value. And here is our other unique one where we again have one variable. We have the equation x equals 1. Again, writing it as ax plus by equals c. That would be x plus 0y equals 1. And now we separate it. X-intercept, y equals 0. So x plus 0 times 0 equals 1. We get x plus 0 equals 1. X equals 1. That's my x-intercept. And to find my y-intercept, I'm going to plug in 0 for x. So we get 0 plus 0y equals 1. We're isolating for y. 0 plus 0y is 0y. And then we divide by 0. And we get y equals no y-intercept. So it's not going to cross the y-axis. So if my x-intercept is 1, on the x-axis 1, and it says every single, no matter what I plug in for y, my x is going to be 1. So where's another place my x can be 1? It can be 1 here. It can be 1 here. This coordinate is 1, -4. Notice my x value. This coordinate is 1, 0. That's my intercept. This is 1, 2. Notice all of them, no matter what my y value, no matter at 2, 0, -4, I'm always going to get x equals 1. Because look at that statement. It says x equals 1. It's a very strong statement. X is always going to equal 1. What does that graph look like? It looks like that. Notice it does not cross the y-axis, hence why we have no y-intercept. All right, hope that helps. There were some interesting ones that will definitely test your mettle. And come and see me if you have questions.